Good morning. This is Alight School, Nushaira campus. It's our chemistry class. Alhamdulillah, we covered our last lesson. The last chapter was environmental chemistry of atmosphere, right? Okay, so our today's chapter is related to organic compounds and its study, and the study of organic compounds is called as organic chemistry, and your chapter's name is organic chemistry as well. Okay, so what organic compounds actually are? Initially, at the very start, what happened that people and the scientists, of course, they were thinking that organic compounds are those compounds which are derived from living things. Up till now, I told you that the compounds are divided into two sections. Some are organic compounds and some are inorganic compounds, right? So the initial concept or the beginning concept related to compounds were that those compounds which are obtained from or which are derived from living things, they are known as organic compounds. Whereas those compounds which are obtained from rocks or non-living things, they are called as inorganic compounds. So, do you think that it is okay? Scientists were thinking that yes, this distribution is okay. Organic compounds are those, because when they looked into the living organisms, what did they found? They found fats. So yes, fat is an organic compound. They found carbohydrates. So yes, carbohydrates are organic compounds. They found glucose. Yes, glucose is an organic compound. So those compounds, okay, so in the plants there was glucose. Plants are living organisms, right? So those compounds which are found in in living things, they were known as organic compounds. Then what about sodium chloride? So sodium chloride is a salt and it is taken from rocks, right? So sodium chloride was supposed to be an inorganic compound. Okay. Then what happened? Then a Swedish chemist, his name was Berzelius. He gave his theory. According to his theory, all types of organic compounds can only be synthesized if and only if we have a vital force. And as that vital force, that natural force, that supreme force is only in the living organisms, so that is why living organisms or the compounds obtained from living organisms were called as organic compounds. And then people and all scientists, they were thinking that we cannot and we can never make these organic compounds from inorganic or from non-living things, right? And this theory that is why known as what? Vital force theory. According to vital force theory, what was the case? The case was that we can only synthesize or we can only prepare organic compounds if and only if we have a major force. And as the living things have major force means a universal force, a natural force, that force which can never be seen, right? So then what happened? Then I'm again using the word people, but yes, scientists and chemists were doing an experiment in the lab. what did they do? They were actually making something else, but what happened that they took ammonium cyanide. The formula of ammonium cyanide is NH4CnO. Ammonium cyanide is an inorganic compound. What happened that when they heated it, they knew that something else will be formed according to their theory, but what actually happened, they generated urea. The formula of urea is C double bond O NH2 and NH2. Right? Urea is an organic compound. So if you look here, this is an inorganic compound, and from this inorganic compound we have synthesized what? We have synthesized an organic compound. So this means the vital force theory was clearly rejected. That no, we can synthesize organic compounds in the lab without any vital force. Right? Okay. So this story wasn't in your book, but anyhow, it's okay. You got some background. Don't go in more detail. Now, what is the case? The case is that after this formation, this successful formation, scientists tried to prepare more and more organic compounds from inorganic compounds, and nowadays we have several millions. Some people say they are more than 6.6 millions. So many millions of organic compounds are being derived. Okay, and except them, thousands of organic compounds are derived every year, or are prepared every year in the labs in Pakistan, in England, in Australia, in America, everywhere. Organic compounds, or everywhere the scientists are, the researchers, they are planning, they are making, or they are trying to make something new, and thousands of organic compounds are still synthesizing. So what is the case? The case is that as there are many of organic compounds, so that is why scientists have divided chemistry into two main parts. One is inorganic chemistry and other is organic chemistry. So organic chemistry is the study of organic compounds, right? But now the question is, what is organic compound according to the new concept? If this concept is wrong, then what could be the new concept? So the new concept is you all are familiar with the new concept, and the new concept is what? Okay, so the new concept is that all compounds having carbon in their structure are called as organic compounds. But how carbon in their structures, or all compounds, carbon containing compounds, that is that except oxides of carbon. There is some exceptions, that those compounds, for example, exceptions are all carbon containing compounds are organic in nature, but there are some exceptions. What are they? They are except oxides of carbon. Oxides of carbon means CO. Carbon monoxide is not an organic compound. Carbon dioxide is not an organic compound, right? Okay, so oxides of organic compound is cancelled. They are not organic compounds. Then we study them in a separate branch. That separate branch is inorganic chemistry. Okay, second is those compounds are organic which are having carbon, but they do not have carbonates. They are not carbonates. Now what are carbonates? Carbonates are the structures. Carbonate, whenever you get the name carbonate, you just have to think that carbon is bonded with 4 of the oxygens. Okay, now look here. Carbon can make 4 bonds. 1, 2, 3, 4. That is okay. Carbon valency is satisfied. Oxygen can make 2 bonds. So 1, 2, that is okay. In this case, oxygen has made 1 bond. This means that this oxygen needs another positive charge to be neutral, or needs to be bonded with something. It has an electron. It also has an electron. This has made only 1 electron. Now if I want to make sodium carbonate, so sodium has a charge of plus. So 1 sodium ion would come over here, 1 sodium ion would come over here, and as a result they will make it positive. So carbonates are not organic compounds, but they are inorganic compounds, right? Except them, bicarbonates are also not organic compounds. What are bicarbonates now? If you remember, in our class we discussed that carbonates are CO3 with a hydrogen atom with them. So we can say that hydroxide, right? So that is, the structure is C double bond O, O and OH. So this is hydroxide. Now look at the valency. 1, 2, 3, 4. Carbon has completed its valency. Oxygen 2, that is completed. Over here, oxygen can make 2, so 1 is completed and other is with hydrogen. So this oxygen has also completed its valency, whereas it will require something, right? So it has a negative charge. What will happen? That a sodium ion will come over here and it will satisfy it. So sodium bicarbonate, NaHCO3. Sodium bicarbonate or bicarbonates, all bicarbonates are not organic compounds, but they are inorganic compounds. So oxides of carbon, carbonates, bicarbonates, and some metal carbides. Metal carbides, carbide. What are carbides now? Carbides are carbon always bonded to 3 carbon atom, triple bond with other carbon atom. So carbon can make how many bonds? 4, 1, 2, 3, and 1 other. This means that it will require 1 other metal. Same is the case with this carbon. 1, 2, 3, it will require a metal, right? So what is the case? We will need, suppose we are making calcium carbide. So calcium has a charge. Calcium is a member of second group. So this means it has 2 plus, right? So this calcium ion would neither come on this side, neither come on this side, but it will adjust itself at the center somewhere. So what will happen? It will try to make its bond over here, it will try to make its bond over here. So that is, it will make calcium carbide. And the formula is CaC2, right? So all those compounds which are having, or all carbon containing compounds except oxides, carbonates, bicarbonates and metal carbides are called organic compounds, and their study is called as what? Organic chemistry. And in other words, we can also say that organic chemistry is the study of hydrocarbons and their derivatives, okay, and their derivatives. So we can say organic chemistry is the study of hydrocarbons and their derivatives. But now what hydrocarbon is? Hydrocarbon is carbon bonded to hydrogen. That is, if you look at the methane, so what is with the case? Carbon bonded to how many hydrogen? 1, 2, 3, 4. So in this case, carbon is bonded to 4 of the hydrogen atoms. We say it's methane, right? And its derivatives, what does it mean? Sometimes, what do? If we replace this hydrogen with an oxygen, so I'll get CH3 and OH. So it becomes alcohol. From methane gas, I have converted it to alcohol by providing it an oxygen, right? So in this case, what will I say? I'll say that it is the derivative of hydrocarbon. Which hydrocarbon? Methane. So I think it was all for today. It's enough. Just try to understand them, and don't forget that organic compounds can be of two types on the basis of their origin, and that origin is some are naturally occurring organic compounds and some are synthetic. So the naturally occurring organic compound were those which only Berzelius and the early scientists believed that only those compounds can exist and we cannot synthesize in laboratory. But then as we synthesize them, so yes, now they are also the part of organic compounds. In naturally occurring compounds, carbon containing compounds or organic compounds, we can say carbohydrates or the glucose, right? Whereas in synthesized, we can take the example of different drugs. Drugs mean medicines, right? If you look on a bottle of medicine, so you will get many names of organic compounds, like it's having benzene. Just try to take a medicine bottle today and find if there is any structure like this, or if there is any structure like this. What can see? Like this, right? So try to understand, read your page number 50 carefully, and that is only 50, right? Because our topic went quite long. So try to understand. If there is anything which you feel hard to know, please do ask me once again. I'll explain that. Visit your Google Classroom for checking your homework if there is any. I have given you the homework earlier. That is an assignment and you have to do that, right? Thank you very much. Allah Hafiz. Bye-bye.